Having introduced the graph of arcsine, or the inverse of sine, we're now interested in the calculus property of finding the derivative of arcsine. Now this is not a trivial one, but it can be calculated using the rules that we know from our other derivative skills. In particular, we can start off with an interesting relationship. Sine and arcsine of each other are inverses. And one of the properties of inverses, just like ln of e to the x, when we have taken x, apply e, and then take the ln, we get back to our original value. I get back to x. Exactly the same thing is true for sine and arcsine. So if we start with x, treat that as a ratio, work back to an angle, then run that angle through the sine function, we return back to x because of that inverse relationship. Now, what we're interested in doing is finding out what is the derivative of arcsine of x. Now we could just give a simple formula, but I think it's actually a little more interesting, and it gives us a nice prelude to some later material, if we compute this derivative sort of indirectly. Let's start off with this equation up top. Sine of arcsine of x equals x. Now that's an equality. Both of these things are equal to one another. So what we can do is, as long as we do the same thing to both sides, we can transform both sides. The way we're going to do that is we're going to differentiate both sides. Instead of adding or subtracting an amount, we're going to differentiate it. And that's perfectly legal, and in fact on the right hand side it's very easy too. The derivative of x is just 1. The left hand side is a little more complicated, but not too bad. Notice that we have the derivative of sine of something. We've seen the derivative of that. Now the complicated part is the derivative of sine anything is cos of the same thing times the derivative of the inside. So we get a derivative of arcsine of x after that. Well, why is that interesting? It's because everything we see here we know. The only thing that is not known is the derivative of arcsine of x. Well, that's exactly what we want. We want to know that. So all we have to do is rearrange, and we can get an alternate expression for the derivative of arcsine of x. If we keep it on the left-hand side, we have a 1 on the right-hand side, and then we're going to divide both sides by cos of arcsine of x, which is great. So we have that solving. We've solved for the derivative of arcsine of x, and we're going to simplify that a little bit further. So the derivative of arcsine of x is equal to 1 over cos arcsine of x. And this is what we would classify in math as something that's true but not useful. Who wants to calculate something horrible like this? Pretty much nobody. So fortunately there is a way to rewrite this so that it is much cleaner and much easier to use, and we base it on the relationship that cos squared of an angle plus sine squared of an angle adds up to 1, courtesy of that earlier relationship of Pythagoras and the unit circle. If we isolate cos, we can get that cos of an angle is the square root of 1 minus sine squared. How does that help us here? Well, cos of what is what we're interested in. We're interested in cos of arcsine. So we can simply replace the cos in the denominator there with 1 minus sine squared of the same thing. Square root of 1 minus sine squared of whatever was inside the cos, which in this case here is arcsine. And then we get a super long radical, or square root sign, and there we go. Now why is that any better? Well, before we had cos of arcsine. That wasn't very helpful. Sine of arcsine is very helpful, especially when we remember that the squared could just as easily be written as the entire thing squared. So sine of arcsine of x is actually where we started all of this. Going back one page, sine of arcsine of x is just x itself, because taking the arcsine, then taking the sine, gets you back to where you started. So here, we can have 1 over the square root of 1 minus sine of arcsine, well that's just x, and then we still have that little squared left over. There we go. That would be the true and useful derivative formula for arcsine of x. The derivative of arcsine of x is 1 over square root of 1 minus x squared. And it's just worth recapitulating the process we took there. We didn't assume anything. We simply recognized that arcsine is defined to be the inverse of sine, so these would cancel. We could make an equation. From that equation, we just differentiated both sides and carefully applied the rules of differentiation and then a trig identity to be able to simplify that unknown derivative, the derivative of arcsine of x.